Good morning, everyone. I welcome you all for this most exciting panel. This panel is coming to you with the VLSI Society of India, VSI, and Electronics for You. Both entities have been in this area for quite some time, and I'm very happy to have the most accomplished leaders here, part of this panel. And over to you, Satya.
Thank you, Chitra, and thank you, Ananya and EFI for setting this up. We all basically coming from semiconductor industry are experiencing the most exciting time in at least my 25-30 years in this industry, both basically globally and in India. I think today, at least what I see, earlier semiconductor and chips were basically known to a few accomplished people, right? But today, every kid talks about basically chip shortage, right? So because of the chip shortage, everybody knows about the semiconductor very well. And also, all the world has realized the strategic importance and how semiconductor and electronics affect day-to-day life and everything we do, from the infrastructure to day-to-day life, telecom, cell phone, whatever we do basically depends so much on semiconductors. And because of that, almost every major country in the world has put up the significant plans and investment to basically in the semiconductor industry. If I just basically take a broad estimate, probably it's at more than $200 billion have been committed in next 5 years by different countries and different companies to this field, right? Considering the strategic importance of this, India has also basically come up with a very strong progressive incentive policy with $10 billion investment covering all aspects of the semiconductor industry, which is semiconductor product design, semiconductor manufacturing, and research and talent. So first time in last 15 years or so, I have seen a policy which is very comprehensive and also very good in terms of basically providing the incentives. So taking the things from there, in today's panel, we are going to focus on the semiconductor product and the chip industry, part of the semiconductor ecosystem. As probably all of you know that semiconductor product companies like Qualcomm, Nvidia, they are the major driver of the innovation in this industry. They create the products which get manufactured in the semiconductor plants, which are called fabs. In some sense, the products or semiconductor chips are the fulcrum of the whole industry. And in today's session, along with the EFI, we are going to focus on building a very strong, vibrant, and robust ecosystem for semiconductor product and the chip design in India. We were fortunate to get basically some of the most influential global leaders from industry, academia, overall basically driver of the new ideas for this panel. And we are going to hear from them that how we can leverage their knowledge and best practices and experience to build a very strong semiconductor product design ecosystem in India. So with me on this panel, we have Navid Sherwani, Mike Wishart, Subhashish Mitra, and Vivek Khaneja. I had a good fortunate for knowing all of these people for a long time and have also worked with a lot of them. So I'll start with Navid. Navid Sherwani started his career as a professor at University of Michigan at Kalamazoo. But his journey from professor to one of the most influential leader in this industry has been incredible. And we started our entrepreneurial journey together with Intel Microelectronics and then So Naveed is currently CEO of Rapid Silicon, but that's not the only thing it does. He is also driving the open FPGA platform. He was the key person who built the whole RISC-V momentum when he was at Sci-Fi. And he has so many basically things which he has done in the life. One of the most impressive idea guy, if I say so. Mike Wishart, who is currently CEO of eFabless, has been very influential leader in this space. Board member of Cyprus, Noel's. He was basically at Goldman Sachs, so he understands both the business side and the technology side of this industry. As eFabless, he is driving, democratizing way the small, medium companies do silicon products, how to provide them easy access, open EDA tools, access to fab, and many things which will enable very large number of people to start participating in this area and lowering the barrier. Next, we have Professor Subhashish Mitra. He is at Stanford. Very, very interesting work in variety of areas. He has also worked at Intel, so he has both industry and academic experience. Some of the very interesting work he has done. He is the leading scientist for building the real computing system out of the carbon nanotubes. He also is driving a heterogeneous integration of different technologies on a single wafer, so that you don't have to build one chip for sensor, one chip for basically compute, one chip for memory. He's driving that initiative, and all of these technologies can be put on the single wafer. He is working on the AI ML chips, data centers, and so many other things. So very, very interesting body of the work with Subhashish involved. Yeah. And then we have Vivek Khaneja, who is the executive director at CDAC. Before that, for a long time, he was basically driving the associate design at ST Micro in India, one of the key leaders. So probably about 50 plus years he worked. So he understands both the government and public sector side as a part of the CDAC, and he's driving a lot of initiative on the behalf of government as part of the CDAC. But he comes from a very rich chip design and IP design background as well, right? So, so I think I could not have got a better set of influential leaders for this panel. So thank you all of you for joining. And I'm Satya Gupta. I think
I introduce you. I think it would be incomplete without introducing Dr. Satya Gupta. I had a great fortune to know Dr. Satya when he was a PhD student. And one time what happened is there was an international conference on parallel computing in Chicago. And his professor asked me that, Dr. Shivani, I have a PhD student who could not find a room in the conference. So can he sleep with you in your room? So that's how I know Satya for the first time. Then we went away on our own way. And then in 1998, 99, starting Intel Microelectronics, Satya showed up. Satya said, I'm going to stand with you. And we started Intel Microelectronics. I think the greatest gift I can say Satya did for India, that when we decided to expand our team, he said, I'm going to go to India and set up a shop where we will tape out all these chips. And at that time in 2002, 2003, we had a lot of demand for taping out a whole bunch of chips. And Satya and Chitra, who's also in this call, they did something great for India. I think so. And what they did, they showed that it's possible to do hundreds of tape outs in India, which at that time was not possible. And I think that's what Satya's gift to India was. And I think India has to be very proud of people like Satya and what Satya has done for India. And a thorough gentleman, I've known him for a very long time. He has went on to do many, many great companies in India. But more importantly, he is currently providing the leadership in India to taking India forward from a nation point of view in chip design. And I think I'm really proud to be associated with Satya in a small way.
Thank you so much, Navid. So I think, as I said in the opening remarks, the focus of the panel discussion we will have is how to build a semiconductor product and the chip ecosystem. So we can have many more small and large companies coming out of this effort. And I think a lot of you have been basically part of developing that ecosystem worldwide, some from the industry, some from the academia. So I'll start with Navid. So Navid, you kind of started your entrepreneurial journey with Intel Microelectronics and then Open Silicon, and then you have done more things, right? And you are also connected with the various geographies in the world, right? So how do you see currently the chip design ecosystem worldwide, and India can evolve from wherever it is? What are the key drivers? What are the key barriers? What needs to be done? What is lacking? What is there, right? So if you can share your perspective, because you are involved with so many startups in the chip design area.
So thank you, Satya. I think if there is any one nation that can emerge as a superpower of chip product area, chip design, actually, along with China, I would say because of the head count, India has to be there. And here is the reason. India has a very large number of people who have good 20, 25 years of experience of taping out devices, front end, IP development, package, test, everything. How many nations can you tell me? I mean, you go Malaysia, they may have back end package. You go to Thailand, something else, Vietnam, something else. But how many nations can you say has, I would pick a number, 100, 200, 300,000 people who have worked at Intel and NVIDIA and Qualcomm and so on. So I think from a pool of senior trained people who can actually do the work that we are talking about is available in India. What is missing? This whole thing is there. We have to just light this fire. That's all that's needed. And I think if we can light this fire, we can have a very great product ecosystem in India. And I think India is ready for it. I think Indian government incentive is good, but I think we need to do a lot more than that. And I think what is missing is that somehow, in my view, we have never connected the universities, the researchers, and the companies that are investing in India in design services or their design centers. We have really not connected. And because of whatever reason, my favorite quote is, because they paid the people so well, there was really never true incentive for those people to leave and go start their startups. But I think we are at the right point, and I think it's a matter of giving the right incentives to these senior people so that they can all find their startups. And second, I think important thing for India would be to focus not on the global semiconductor industry. It's good to do that, but also focus on India and Indian needs, or what are the specific chips we can do for India. They don't have to be fancy. Let's not work about 100 gig SerDes and chips that work. We can start with some IoT chips. We can start with things which are relevant to India, easier to make, easier to tape out, lower cost, things of that nature. So my suggestion would be is to tap into this humongous trained manpower resource that we have in India, create an incentive plan, focus on India, work on low cost, simple chips, start there. And I think that might be the magic that we need to incite this fire. Once the fire starts, I think India will take off like a rocket. This is my opinion.
Good. Thanks, Navid. Since you mentioned about how the academic ecosystem can put basically some of these things in the forefront, I'll ask Subhashish to share his view. If you see in the Silicon Valley, a lot of these chip companies come out of the academic research or academic collaboration with industry at Stanford, Berkeley, UCLA, and all those places, right? California is certainly a breeding ground for the chip product companies, right? So what can we learn from that ecosystem to build the similar kind of the symbiotic relationship between academic research and industry, and what are the some factors which may be more India specific? How can we kind of create a Silicon Valley type of the culture between academic and industry to put that fire which Naveed is talking about?
Okay, thank you very much. First of all, thank you very much, Satya and Chitra, for having me as part of the panel. You asked a loaded question, and I think we'll be here for the next, whatever number of hours, if you want to get deep into this thing. But I will point out kind of three aspects of, semiconductors in general and chip design ecosystem and so on, where I think the US universities have, made a big mark, right? So if you think of the three aspects, and these are not, all of these are not necessarily Silicon Valley aspects, things have happened outside the Silicon Valley as well. So first of all, obviously, chip startups or, companies that have been formed. There was a fantastic idea that came out of academia where they targeted a specific problem. If you think about 1980s, that was how to build a microprocessor that was, simpler within quotes, to chips for networking, chips for communication systems, all the way to, for example, chips for AI, for example, and so on and so forth. So there, the way it happened, I think, is you pick a problem that you see that if that problem is solved, there would be a big impact, right? And then you target that end-to-end sort of a thing. What needs to happen so that some particular problem is solved? You just talked about IoT, like many people talk about edge AI. If we have to solve the edge AI problem, what are the capabilities that a system needs? And then go and build a system, not just a chip, but also all the stuff that comes with it, to build a system so that that's possible. And I can get into details of my personal experiences in all this, but I'll set that aside. So that's one aspect, and that's a big aspect. And I think, Satya, you're probably talking about that aspect very significantly. But there are two other aspects as well where US academia has done very well. And why am I talking about US academia in this Indian context? Because I think the expertise that's needed for each of these things, I think India has that. So what are the other two? So the second one is kind of create the fundamental technologies. So this is not about the specific chips for a microprocessor or for, edge AI or, and whatnot. This is about how do we create the next technologies, right? That will enable the next generation of chips. And that's where, at Stanford and other places, MIT, Stanford and other places, they have made, really big impact. May not be startups, but not everything has to happen through startups. Professor Chen Ming Hu from Berkeley, he invented the FinFET. That has revolutionized the world, right? One of my former students, Max Schulaker, he is now a professor at MIT. And, he has played this major role in bringing these heterogeneous technologies in 3D, in actual foundries and actual semiconductor companies, right? So that's the next one. But again, the formula is the same. You pick a problem that is really important and really big and try to find an end-to-end solution to that, right? For the case of the FinFET, it was, hey, the planar transistors are not going to scale. So what do you do, right? But do the whole thing. It's a lot of pain, but at the end, there's a lot of gain, right? So that's the second aspect. And the third aspect we often forget, which is the EDA aspect or the electronic design automation aspect. It's the same story, right? If you think of the innovations and the startups that happen in that space, again, you see the same formula: pick a problem, solve that problem, and make a real impact. Why can India do all these three? Because if you look at the expertise in India, the first one, Indians are really good at creativity that's directly connected to chip design, and at the same time, the Indians are very good at math. That's really connected to logic and so on and so forth. So there is no reason that India should not shine there. The second one, think of semiconductors, right? Semiconductor technologies themselves, innovations there. India has a very strong background. I know of many colleagues that are like super experts in that. And the third is EDA, electronic design automation. It's the same story. So I really think that collectively, India has, this is going to be the century where India can make a major mark in these three aspects.
Thanks,
Still muted
Subhashish.
there.
I think another thing, basically, people always talk about the semiconductor chip companies is the cost of entry barrier, right? Whether it's a EDA tool, prototype manufacturing, manpower cost, all of that, right? Compared to software, which is software startup and companies have flourished in India. We say 40 unicorns now and all of those things, right? And whenever we talk, everybody says that the cost of entry in this specifically particular area, hardware and specifically semiconductor, is very high. Want to pose that question to Mike. As part of eFabless and your other efforts in the industry, right? You are basically involved with so many other things, right? What are the things happening at eFabless and things like Open EDA and all of those things, which can help small companies and a lot more people to participate? Because if instead of 100,000 people can participate in this, obviously the success rate will be better. So can you share your views on how we can create it like a very large number of people participate in this industry?
Sure, sure. So no, thanks, and thanks also for including me in this. This is even listening to all the others. This is really helpful and interesting for me. So basically, as you said, I my career was for 30 years was raising money for companies, and last several years I've gotten humbled by trying to raise money for my own chip company. So I have a lot of sympathy for the basic problem. We did reach success, right? And I think a big part of the answer to your question of getting companies funded and up and running, it is in fact persistence. And I think anybody who's tried to start a company in the area, I'm sure, Satya, you could speak to the same. It's there's quite a bit of that. But at the end of the day, I think you're highlighting a couple very interesting points, right? So, basically, why did we start eFabless? We started eFabless with a mantra of getting back to two people in the garage to create something. How do you really simplify the process and change things? And the dilemma that we were looking at was you have an existing ecosystem that was really built around and consolidated around creating standard products for mass markets, right? So the basic model was pour a tremendous amount of money into capital equipment and R&D, create a product, and you sell a lot of them, and you enable PCs and phones and things like that. And I'm exaggerating. There's obviously lots and lots of niche markets, and we could pick at that. But in terms of a overall structure that sort of guided the industry, that was a big part of it. And out of that has come a very, what we would at least observe to be a very siloed industry. You had capabilities in EDA, you had capabilities in IP, you had manufacturers who would protect their PDKs and all of this, and all, obviously extremely understandable and the engines to really drive the great world we're in today. The problem is that over 40 years of doing this, not only did it get really expensive to start a company, but it's also, incredibly time consuming. So when you come back to things like open source, and I would say open source EDA, but I would also say open source IPs, we created open source chips, fully open source chips that could be shared. You now see an open source PDK. This world is a little bit about the cost. It certainly helps that, but it's also a lot about the simplification and the sharing. So, I think others on this panel could speak a lot more articulately than I can about reuse, but in general, reuse was reuse within companies, right? What we envisioned was, if you really open up a world and instead of thinking of people as siloed designers, think of people as chip creators, what do you do to give them everything very quickly to go to work to get something done? And so that's the EDA, it's the IP, it's all of that. And it's not just open source, but trying to bring up models that can protect people's proprietary investments, but still get some of the benefits of that openness, immediate access to proprietary IPs. So we develop open source chips that have got proprietary ARM IP within them, for instance. We actually collaborated and demonstrated that with Mentor at one point, so proprietary EDA in there too. So we imagine a kind of a mixed mode world, but at the end of the day, you have to build on these principles that you saw in software of sharing and removing those barriers to get started. So we would say part of that's open source. We would argue that part of that is establishing platforms. By platform, I don't mean a chip platform. I mean literally an ecosystem in a box where things can be protected, but people can get very quick access. So we think this whole ecosystem needs to be created. Now, at the end of the day, what is this going to do? We think this is a market expander. So we think the stuff that gets created through our platform will be true to the principle of good enough, right? It's not going to be true. We're not pursuing perfect, right? We're not, in fact, the people coming to our platform are not pursuing perfect. They're pursuing good enough, something to get started, something to knock the barriers down, something so that they can now have something in their hands, a workable chip, a prototype that they can go out and demonstrate to the world, you know, what they want to do. So I think that is going to take a turning the world a little bit on its head, move at least for the inspiration and the creativity portion, move into a world of sharing and community, and away from the silos. That's at least what we're doing, and we're having some success.
So Vivek, coming to you, as part of the HT and now part of the CDEC, you probably interact with a lot of aspirant startups or existing startups in the chip design area in India. So what do you see that they feel they need to basically make a successful chip design company, which not only just create a product, but create a scalable product which can basically go to millions of units? And what is your experience when you interact with these startups? And then you can tie up that how government is trying to solve this problem through the design link incentive scheme, which they have announced recently. So what are the typical problems when people come to you, you see, and then how we are trying to solve it?
So thank you, Satya, for inviting me. Thank you, Chitra. And it has been wonderful to hear the thoughts from all these leaders who are luminaries in their respective fields. Coming to the first part of your question, Satya, about the challenges that today a typical startup or an MSME will face, especially in the chip design, as has been brought up by the expert Navedji, that the entry barrier to this particular segment of the market or design is extremely hard. If you compare that with a startup that is purely on the software development side, the entry barriers are relatively low. So of course, the first challenge these guys face is that the cost of the EDA tools today are prohibitively expensive. Almost about, let's say, about 25% of the total cost of the entire design chain is attributable to the cost of the EDA tools. To some extent, that is being addressed by people like eFabless and other open source, open domain EDA tools. But let's face the fact that today the standard offerings from the top three is beyond the reach of a small startup. So EDA tools for sure takes the first point one for the issue that these guys face. The second one is the availability of IPs and cores. Now, when you're looking at a problem and you are trying to solve that problem, you will create a solution which will have some sort of a programmability, it will have some sort of peripheral IPs. Getting hold of those IPs which are silicon proven is today not easy, point one. And secondly, it's not cheap. So availability of IPs and cores at an affordable price is a second problem which these startups face. Of course, you have open source and some IPs that are available, but then the quality of those IPs, the aspect of integrating those IPs in your design will have to be seen. Another aspect that typically these guys will they are facing is that the cost of making a prototype is again high. These guys have smaller numbers, and typically the foundries will not really give them that much leverage when it comes to doing a prototyping. That's where I think the efforts that are happening at eFabless and similar efforts world over, where you can share the cost of the shuttle and open source PDKs are available to the, will bring down the cost to some extent, so that at least a prototype can be made by these people as a proof of concept before they start to actually scale up. So these are typically, I believe, in the main challenges that these guys are facing. And of course, apart from that, to attract the funding for a chip startup today, at least in India, is slightly more difficult as compared to attracting VC funding for a software or another startup that is into let's say supply chain disruption kind of a thing. So you have people putting their money on Mintras and Flipkarts and Nykas, but very few will put their dollars in a chip startup, because the chances of failure and the cost of failure is much higher here. So those typically are the problems that we have seen people come back and often report. And based on these problems, the government of India has tried to address some of these problems to at least help the startups to bootstrap quickly in the area of semiconductor design. Recently, in the last week of December, in fact, on 21st of December 2021, the government of India announced a very comprehensive semiconductor program to bootstrap the Indian semiconductor industry. So this is typically divided into two parts. One part which is focusing on the development of semiconductor fabs, which includes display fabs, the CMOS fabs, and also the development of an ecosystem for ATMPs, OSATs, and compound semiconductor silicon photonics. That's one part, which is mainly on the fabrication side. The second incentive is on the startup ecosystems for the semiconductor design. The idea is to somehow offset some of these entry barriers and provide incentives to MSME startups and domestic companies to at least have some support initially in these domains. So under this, there is a plan to create a national EDA tool grid, so that the this challenge of providing access to the EDA tools for the startups can be addressed to a large extent. In terms of the MPW support, the government has also announced that as part of the infrastructure support, we will create tie-ups with aggregators like IMAC, eFabless, and similar people to offer slots in the MPW shuttles for startups and MSMEs. And also, we are also trying to put together a kind of system where we will be able to list down all the IPs and cores that are available within the country, which have been developed either through funding from METI or through startups or through other academic and R&D programs. And we will also invite others who will be willing to share their IPs and cores to be made available to these startups. So that's on the infrastructure part that that the government has. Of course, there are other linked incentives that have been offered in this scheme. So this is typically what the government has done to address some of the challenges that the startups are facing.
Vivek, I think that gives a segue into the next question, right? So while you alluded to some of the technical aspect of the barriers for these startups, right? One of the things which we hear from a lot of industry or startup people, successful startup people in India and globally, right? That typically a chip design startup in India is started by a technical person who is working on TI or Intel and all those things, right? So their whole focus is very technical centric, right? What basically a lot of people have seen, and when you give the example of Mintra and all of those people, right? Those are business and customer centric part is very strong in those parts, right? True. One of the things which we feel, even for the raising the fund and all those things, right, is that very strong customer and business focus in the team and the approach is missing, because the team is also composed of 3-4 technical guys, right? They don't have a strong business guy. They don't have a very customer centric approach, right? So maybe Naveed, you have done a lot of this customer centric products and things like that. So is that something which needs to be addressed, and how do we address to bring that customer and business focus to these startups so that they are not just thinking about creating a cool technology and only thinking about EDA tools and MPWs and all of those things, right? Which are kind of a solvable problem, right? I think, but business and customer centric thing, right? I think that is what makes a startup successful. And Subhashish also mentioned that you should focus on solving a problem, right? Not about that I have a technology, I have to do something with it, right? So any of you, Naveed or Subhashish, you can pick it up and see how do we create this business and customer centric approach.
So let me, of course, I'll be very interested in listening to Professor Mitra's comments. My comment is that while a lot of design moved to India, design decision never moved to India. In other words, Intel may have 7,000 people in India, 10,000 people. Qualcomm may have 5,000 people in India, but no decision makers are there. The people who are buying the chips, people who are interacting, they all were in US. Actually, they are nowhere else in the world too. So I think one key thing that never happened, I'm just trying to, why it did happen, I'm trying to figure out so that we can see how we can fix the problem. So chip buyers, people who specify and design what chip needs to be designed, they were never in India. Execution was in India, right? And that was the focus. And lately some has moved there, but still, I think the most of the people are executing. And so that talent was never, probably it was not interest of Intel and Qualcomm and others to do that. They just wanted India as an outsource center to do a lot of work, right? So that was missing. Secondly, I think somebody pointed out, I think Professor Mitra pointed out, that the cost, if you are an entrepreneur, the cost of doing a software startup versus a hardware startup, I mean, as a logical person, if you are just looking out for yourself, you should do a software startup, common sense. It's also true for VCs. And that's why we lost a lot of VCs in the Bay Area. They don't want to do hardware startup because it makes no sense. So how do we turn the tide? So that's the question, right? I think the tide will be only turned by making sure that there is a local demand of locally produced chips. If the Indian government has made such a big step forward, $11 billion, and I think a very elaborate and very noteworthy and actually some commendable program. I really salute India government for doing that. But I think there should also be provisions that if a chip is designed and produced in India, there should be some benefit for that. Because every government is doing that. I mean, is that not US doing that? Is that China not doing that? So I think the time has come that maybe India should also think about that. Okay, I'm not saying you put a barrier to the entry of other chips, I think there should definitely be some incentives to say that, okay, and I'm not talking about big chips like, processor chips and things like that. I'm talking about simple IoT chips, simple chips. And if we just simply say that if you are assembling some, toasters, washing machines, refrigerators and things like that, of course, there are a lot of IoT chips, there are microcontrollers and things like that. I'm surprised, why are they not made in India? And I think those is the one aspect I would like to encourage is, as part of this overwhelming plan, I think we should also think about how we can create some incentives for those startups in India. But I think the second part is that we do not have a local VC infrastructure in India. Because again, you need to do that. I mean, the VCs mostly are US VCs or some other VCs who transplanted their offices into India, and they're like coordinating with US, and they're trying to figure out what can we do in India. Again, Indian VCs are not there. There are few small, and again, targeted more on software. So I think that's another, there is no plan in this $11 billion for the VC ecosystem. As far as I mean, maybe Satya, you or I think others can educate me, but as I read this plan, I did not see anything at all to support the VC infrastructure in India. So to me, these are the two things that we should do. Of course, people respond to market. If these incentives are there, people will create. And the last thing would be is that what can be done to do a reverse brain drain. We have so many interesting Indian entrepreneurs in US. Can we create an incentive for them so that rather than doing their startup in Bay Area or in US, they may go back to India? And again, I do not see any incentive for that as well. So I think that would be the third source of people that can go back and they can start that, because they already have experience, they may have done. And we can say, okay, if you bring your startup to India, here is something we do for you. We will pay your design tool cost. We will pay half the salary of your people for the first 2 years. We will give you free rent or whatever. I mean, these kind of incentives are very common in China. I'll give you an example. I have a company in China, it's called Star 5, along with two other companies, Leap 5 and China 5. We, from a province of Guangdong, there is a city called Shunda, and they gave us $500 million over next 5 years. We signed the agreement already. They said, if you move your 3 startups into Shunda, we will give you $100 million over the next 5 years, matching your expense. So if you spend 50 million, we give you 50 million. If you spend 100, up to 100 million. Imagine that. This is what China is willing to do. Now, if India wants to compete in the international, it has to think like that. So that's what I'm saying. Other nations are doing it. I think India is already doing it. I think 3-4 additional elements which I saw missing in the policy probably can help a long way in this direction.
Thanks, Naveed. Subhashish, Mike, you want to go?
Thanks. And I'll give you a lead in back to you as part of this as well. But I think as we look at this, and I think Naveed makes some very good points. I think you could also, though, come back to basically the life cycle of funding a company, right? It's almost crawl, walk, run, right? So whether it's a software company or a chip company, you have to get to some sort of a proof of concept. That's the crawl. And then you got to build a product, and then you got to scale it. The funding differences between software and chips are not that big on the walk and the run part. It's the getting started part that's the killer, right? That's the part that destroys the return, and that's the part that makes all the venture capitalists run for the hills. And so, Vivek, I was really interested in hearing what you were describing, because that is, very much how we sort of thought about building the platform. How do you get people access to the PDKs, the IP, and how do you do that under business models that can let people get up and running and do it extremely inexpensively? So, we're seeing the first commercial things come through our platform now, where people are doing, for example, security chips, and they're using the open source tools, and they're getting to something good enough for $10,000, right? So that's something they can do. I think the other thing that's is interesting. Here's where, among your other comments, Professor Mitra, I'd like to hear you opine on this. But I think what we're seeing is sort of a recollapsing of the chips back to the systems. So rather than a chip industry and a system company, you have this, so-called special purpose silicon, right, that's focused around a particular application. Your colleague Priyanka did a great podcast on this. I'm sure it's a topic you were highlighting some of this in your own comments. But as that happens, then the dynamic changes, right? You get such performance benefits from getting special purpose. You can make a lot of compromises. You can compromise on process technology, compromise on other things, but you have to get the design done. So a big part of, I think, what has to happen is you have to embrace those people, make it easy enough for people to make their own silicon that's good enough, right? Whether that's sharing what other people have done or the model. But I think that's important. And at least today, we're seeing maybe a third of the people coming to our platform are hardware and software developers, not chip developers, looking to create the first chips. But anyhow, that's.
Thanks, Mike.
I think, both Mike and Naveed, they brought up important points. If I may add like one or two, or, even reflect on their points that were made, I think going back to Mike's points, I think, like he made this, like, thank you for making that point about how, hardware and software developers are kind of using your platform rather than the chip designers. I think that's kind of is the end-to-end aspect that I was talking about. At the end, it has to solve a real problem. You can demonstrate a high-speed SerDes or a wireline circuit or something like that. But at the end, to be able to make a real impact, it has to solve a real problem, right? And Naveed was making this point about, how do we enable startups? I think one important aspect of startups is the idea, right? And, being an academic, I think I'm biased, obviously, right? I think the best ideas come from academia. I just wanted to inject a little, controversy into this thing. So I think the real question is, how can we get, really great ideas in this hardware space for this kind of end-to-end solutions to things coming from Indian academia? And I think when we are successful in doing that, I think the ideas themselves will be so great that they will be so compelling that people will fund those things. Now I understand that this might be a little bit of an ivory tower thing to say, but I truly believe in it, because I think if you look at the tectonic shifts that happened, like the big impact stuff that happened, that mostly came from academia. It did not come from industry. That's what I would like to say. Yeah.
So, Subhashish, one thing, just follow-on thing. There are basically a lot of learning from the US academic ecosystem we can take. I don't see very strong and systematic collaboration between India academics and the US academics, although it's same people, so many basically Indians are there in the US academics also, but I don't see a very meaningful and systematic collaboration between the two academic ecosystem. How can we do that so that both of us benefit?
By the way, Vivek wanted to say something. Vivek, do you want to go first, and then I can take that one? This one is a tricky question, and and I have
that's
to.
That's why you are there, Subhashish. That's
the answer. But I know the answer to this, But go ahead, Vivek. You wanted to say something?
Thank you, Professor Mitra. I have just two remarks to make. One to the point that Naveed made about providing some sort of a professional market access to those people who are making the designs in India. It's not written in black and white very clearly in the policy, but there is a provision to identify certain areas, certain strategic areas where there can be a provision made to give them what is called as a PMA, or a preferential market access in certain areas, which could be strategic, which could be defense related, which could be something something else. But yes, I do agree with you that unless that kind of a cushion is provided to these startups, it will be difficult to attract them into this domain. And yes, the other point that you raised about a ecosystem for the VC funding that is not as thriving as you have in US is a point very well made, and I really take that's a lacuna that needs to be filled as early as possible. Regarding the comment of Professor Mitra that in terms of making designs in academics and the top ideas come from the academicians, it's a debatable point. But just to add my 2 cents to it, and Satya also knows about this program. There is something called as a Semiconductor Manpower Development Program, or SMDP, which has been put in place for the last many years. It is now moved into its new phase, which we are calling as the Chip to Startup or C2S program, where effectively we are trying to support the various colleges and academic institutes and encourage the undergrads and the graduate students to do their own chip design. We provide them all the handholding support in terms of the tools and also access to the foundry. That has to some extent lit a small fire in the belly for those people who really want to give it a shot. And for them, the next possible logical stop would be to move into the DLI once they have proven their designs in the academic circles, and then maybe they want to start their own companies. So that's a small beginning that has been made, but we have some way to go.
Highly commendable. This is fantastic. I didn't know of this. That's fantastic.
No, I'll come to that in a minute. Basically, this SMDP program is there. These people are doing. The problem is that, especially what we were talking earlier, it is not a problem centric. It's a more technology centric thinking in this whole SMDP program and C2SD, right? So what Naveed and everybody is saying, if we give them the meaningful problems to solve, which will basically have some customer requirement and so on and so forth, taping out another AFE is not going to change anybody's life, right? And keep doing that basically we are not going to go anywhere, right? So they need to, that's where basically people from industry and other ecosystem can help to give them the meaningful problems to solve. I think they have the capabilities, they have technology, but we keep coming back to this EDA and this and that. I think those are the least of the problem today, in my opinion, right? We need to create interesting problem for our academicians to solve. Whether
ideas, you need the ideas.
We need to give them ideas. Either it come from themselves or we give it to them. Right?
Yeah. So,
Mike?
Actually, no, Professor Mitra, you were about to.
Oh no, I played that trick so that I don't have to answer that question.
Well, I'm gonna somewhat dodge it, but I think the question you're asking, the academics is a big part of it. By the way, I'm with you on that. I'd say 2/3 of the stuff that's coming through our open source platforms are academic projects. Virtually all of them are research related. But what's really interesting, if you look at what happened in software, by basically removing the upfront costs, they took all the know out of innovation, right? So if you have an idea in software, you can put it in an app store and people are either going to buy it, they're not going to buy it, but nobody's there telling you, no, it's a stupid idea, right? And the thing that we like to say is if people had the ability to say no, there would have been Angry Birds, that crazy game, right? If anybody had to judge it. And one of the issues you get into in Silicon is because there's so many things that you have to spend money on, somebody makes a decision of what idea gets elevated and what idea does not get elevated. And so that's a problem, right? Because I think the venture capital industry and the chip industry has been pretty good at picking winners, right? So we like type 1 errors, very few. If they see a winner, they do a pretty good job. We have no idea how many type 2 errors there were of ideas that never saw the light of day. And you can look at 1,000 examples outside. Look at YouTube, right? Look at YouTube. We've gone from a few people who could publish and create videos, studios, to now 50 million people creating videos, and all sorts of stars arise. You know, there is, so I think we need to kind of move to that. A lot of the infrastructure that we tried to create for the prototyping was designed to not only be easy for the designer to get a design on the shuttle, but also to take any of the complication away from the foundry, right? Because the foundries, as you see, foundries don't like to run small runs and that sort of stuff. So what do you do to make their life simpler? But I think as much effort as could possibly be made to remove the ability of anybody saying, no, your project won't go. That's the thing that we got to make go away.
I'd like to make this point. I think this is built on Professor Mitra's point. I was an academician at a long time, so I also believe the grand ideas come from universities. And actually, statistically, we can show that. So we don't have to discuss that. I think India needs something different. And I think the ideas that come from academics are long range, industry changing, and usually require a lot of investment and long gestation period, long investment to make it happen. In US, we have been successful in funding those ideas. Sometimes it takes a company 7, 9 years, 10 years before that product hits the market, but it changes the world. Well, we don't have that kind of patience in India initially. So my suggestion in India would be to focus on low cost chips. I'll be happy to start with microcontrollers. We can take Cypress, Renaissance, their product line, and look at $3, $2 microcontrollers and say, why can't we move them to RISC-V or something else and make them? And there is some incentive for making those microcontrollers. They're 180 nanometer technology, 65 nanometer technology, nothing earth shattering, but they can be done. One, that's a start. It would be nothing to write home about. You're not going to tell your mom that I'm doing a 3 nanometer, which is changing the world. But I think they can be done. Now, I think in China, we can also look at what China is doing, right? I think is a good thing because China is desperate right now. China is desperately trying to build a silicon ecosystem. What they are doing, they're incentivizing people to replace these small chips. You can go get a $3 million funding from the government, and that's all you need, $3 million to take a small, I think the best example is the Cypress is the PSOX foundry. There are 26 chips, $120, $140 million business. If you can design 4 chips and you can look at how much chips are coming into India, you can make a $30, $40 million business out of that. That would be great for an Indian startup. So I like to not think grand. I like to think small, start small, build on it. 3 years of doing these many startups, I think we'll start doing bigger and bigger. And I think this is where we can also provide incentives for these chips coming into India, being used in cell phones, being used in a lot of white goods appliances, in EVs. They're used everywhere. They come in billions of dollars, and they're all like $2, $1, 50 cents. So that would, I would say, those kind of cost reduction, replacement chips made in India focus might be a way where we can start. But I believe that's where academicians are not good at it. They don't think cost reductions. They don't think, that's not the business they are in. They cannot write a paper about it, right? They cannot.
They want breakthrough, right? Basically, they have to work on the breakthrough, right?
So
see, both of the systems have to work. Academics have to work on the big ideas, long-term stuff, and so on and so forth. Poor people have to work on the 50-cent chip, right? Basically, as you said.
So let me address that. And I think panels should have controversies, right? Otherwise, it's not an interesting panel.
That's why I have both of you, right? Naveed and you are famous for creating controversies.
Okay, so I see Naveed's point. His point is that how to light that fire and how to kick that ball, right? And I understand that. But I think equally there is a danger in doing this, is that that ball will be stuck in a local minima, and we will never be able to get out of that. And so there is a plausible scenario that, yeah, you might actually be the backyard for generating these this low cost chips, and cost reduction and so on and so forth, but you never get out of that rut, and big things don't happen, and there are examples of that too. So the question really is, how do you balance that? I fully understand, and that's why I say, I just wanted to say an ivory tower-ish thing, but you have to make money at the end, otherwise who is going to feed all the people? But at the same time, I think unless we think something big and something grand, and so I think we'll be stuck in a local minimum, and this is where I think we have an opportunity. Because if you think about, if we were talking about this when I was a grad student, I think life was kind of boring, and it was hopeless, in the sense that like you just follow a particular path, and and things pretty much followed a particular path, right? And that was the way of innovation. Versus I think right now it's a wild west for hardware. Like you have your great idea, if you can show it, and if it does truly gives you benefits, people will take it. And that's why I think there is an opportunity to think big, which probably would have been difficult before. That would be my 2 cents.
We have to pick up basically a thread from processor architecture, when NVIDIA and some of the basically processor chip companies came up with this big little, right? Basically, they are processor cores which we are doing the heavy lifting, and they are basically other cores which you are doing basically small jobs on a basically 8 processor core or something like that. And I'll give you I don't know how much time we have, but I'll give you a small example, right? That what Naveed was saying and what makes sense in the Indian context, right? India today makes 700 LED bulbs. Okay. And this is domestic product, domestic consumption, domestic manufacturers make those. Now, there is a 10-cent chip goes into every small wattage LED, right? 12 watt and below. Okay. It's a simple chip, all of those things said, but the volume is humongous. Design is simple, volume is humongous, right? And since it's a product is also done by Indian companies, they can decide what to use, right? So what Naveed was saying earlier about microwave and washing machines and other products, one of the problems there is that they may be manufactured in India, but their decision what to use inside those chips are made somewhere else, be it China, South Korea, wherever it is, right? Because those are not products owned by Indian companies, so the whole procurement decision doesn't happen in India, right? But there are products like LED, I said, right? Or smart meters. There, basically, the product decision is also made in India. Are relatively less complex. So that could be the little part of the big little, right? And then basically we work on the state of the art edge AI processor, as Subhash was saying, right? That will be in the big idea, or a heterogeneous chip with sensors, memory, everything on the same chip and those kind of things. That's the big part of it, right? So I think we have to work on big and little, right? I want to touch upon one more topic before we end, right? And I think Mike kind of alluded into this, like the system companies getting into basically semiconductor space, right? Be it Google, be it Amazon, and all those things. And one of the other things which kind of start taking shape, right? Because of the AI, I think you all probably know about it. The Google released a AI-based floor planning tool, right? Now, if that kind of the thing start happening, how do you think EDA will basically kind of look like in next 5 years, right? If software companies or AI ML companies get into this game, right? How will this change the shape of the EDA industry?
I've looked at that tool very well. I mean, we inside OSFPG we have a team that is looking at all AI related tools that are in the market, both on the user side as well as on the designer side. And yes, they will be helpful, and I think they will be helpful for more simpler chips, for more complex chips. Again, I think a human ingenuity, as all of us know, is needed. A master floor planner is still needed. But the iteration that you go through, given the certain instructions, I think AI can help. So I think for complex chips, they will use as a tool, as an assistant. And for simpler chips, we can do a lot more. We have done some experiments with actually Microsoft and others, where we took hundreds of examples of chips which are similar. AI does very well on those. So if you have a similar kind of chip, and actually in our business, there many chips are very similar. They're not dramatically different, right? So I think AI will be very helpful, but whenever you have to do a very innovative chip, even then you have to do iterative work, AI can be helpful. So in those two. But for complex chips, human cannot be taken out of the loop, and the lower, I think floor planning get more integrated into detailed routing, global routing. AI can be very helpful to do more chips, more productivity. But completely replacing human out of this loop seems at the current level of sophistication is not there.
I was not referring to taking human out of it. I was just referring to a larger ecosystem of the software companies getting into EDA space, right? Because if Google can do a floor planning chip today, tomorrow Amazon can do a basically place and route basically algorithm and something like that. So does it expand your EDA thing into very different sphere, right?
It does. It does. I think AI companies will be able to provide tools if they have good interfaces. I think the thing that I think all three EDA companies have resisted to this date, if that happens, that the tools move to the cloud, which they should logically move to the cloud. It doesn't quite work for their sales force, and that's why they don't want to do it. That's my 2 cents opinion. But if it does move to the cloud, then hooking it up with the additional tools on the cloud will really make it very, very useful all over the world. But I think we need to have a big, wider ecosystem, and I think AI will provide that. So I totally agree with you. I think there's a chance of expanding.
So I'll end this thing with one last question. We all talk about the complexity of chip design and cost involved and all those things, and all of us understand the most of the cost is in the back end, right? So just like a foundry has become separate, basically service to the startup or chip design companies, right? And this goes to the back to the open silicon days also. Why does a startup has to do backend? It does not add any value to their ideas.
Right.
It's just a chore which they have to do it to tape out the chip, just like you have to do wafer manufacturing. So why can't there be more basically infrastructure companies which will say we will not do any products, just like Fab does not do any product, but we'll just do your backend. And that basically reduces your tool cost, reduces the manpower cost almost by 80%. Basically, 80% of your cost goes into backend, right? So,
Satya, I just started a company. It's called GSME, Global Microelectronic Services, which does exactly that. So what it does is that it just provides you a number of people. So the cost is not related to the chip. It simply says that we think that effort is going to be X, and that's what it is. Because otherwise, like Open Silicon was trying to take margin from you and trying to make business, that becomes a barrier for people. So I just started a company which does exactly called GSME, and all GSME says, I think you need about 1.5 person for back end, test, package, qualification, all that. And when your needs grow, so the idea is to charge people by the amount of people. It is a low cost service, and I did not do it to make a profitable business. It is a support company for my own companies, but we are going to make it open. And I think that's what you're talking about. It should be just
not just the services part of it, but if they can take care of EDA tool, PW, everything basically.
Everything.
Yeah.
But not take margin from the product.
Not margin for the product. I think that's not a problem.
That's right.
Not a problem. But if I can do like typical thing, if I buy the tool from Synopsys or Cadence, right? I use 20% utilization as a single company. But
Correct.
if backend company is buying those tools, they can make the 80% utilization of those tools. So Mike, any thoughts?
Yeah, that's,
By the
you
way,
know, I
Snowy
think,
also knows that. That's why they want to sell to individual companies.
Yeah.
They sell more seats.
No, we understand what is their motive. We have to solve what is our motive and how do Vivek's problem of EDA tools, right?
Correct.
well, you know, this is part of the benefit of a platform, right? Where you've got effectively a marketplace. We think of a marketplace today in our platform of IP and things like that, but it's also of services. And once you move to that, a very fluid way of engaging and simplify that entire process, then people will start to do what they want to do. People who want to do back end will do it. It'll be easier to get more business. I think that will just happen. And especially if you go to this world that we've talked about here, Professor Mitra and others, David, myself, of system people, non-traditional silicon people getting into business, they're not going to want to make that back end investment. So I think the market will very naturally go there.
I think if there are any summary comments from each of you, I'll just go around and basically maybe we'll start with Vivek and Subhashish, then Mike and Naveed, right? And then we continue. We have about 3-4 minutes left, so short 30-second sound bites, which EFI can publish on their website, right? So.
Okay. So as far as I am concerned, I think we are in for probably the golden period of semiconductor design. It is all pervasive now in almost every sphere of life. And there are interesting things happening all across the globe. The Indian government has also put a strong foot forward to support the semiconductor design ecosystem in place. What needs to be done is to have a problem-centric approach to think of an end-to-end solution for providing for a known problem where some value addition can be done. And then it can be scaled up to start with for local problems and then maybe take it on to a global level. So we are in interesting times and I hope that the Indian semiconductor industry is able to make a quick move and leverage the support ecosystem that is being put in place.
Okay, so I will just, piggyback on what Vivek said, very well said. I would just add a few points. Number one, it's a golden period for not just semiconductor design, but also semiconductor technology, number one. Number two, I truly believe that the big differences will be made by the great ideas in the space of design, technology, and EDA from Indian universities, right? And that's why I think the most important thing is how you motivate the next generation to come up with the big ideas. That will make the big difference, and that's how India will be the leader.
I'll let David have the last word because that's always the most interesting.
Naveed always has the last word, so it doesn't matter who is speaking, right?
And as he should. So first of all, I do want to thank you for letting me participate in this. Extremely cool. I completely agree with the comments on the exciting next world that's arising. I would also say, Vivek, what you outlined for a infrastructure to really get silicon going in a more democratized world, I would have to say is right on and is very forward thinking. So I think it's going to be exciting to watch.
I think India is extremely well positioned to become a world leader. I think what can stop India is only India. There is nothing else stopping India. I think we have the manpower, we have the vision, we have what it takes, and the investment infrastructure is coming in. What is, I think, needed now is a group of people, and it takes very few, 5, 6, 10, 15 Indians who have to decide, we are going to make India great. I think we need those people. Somebody can be in the microcontroller space, somebody can be AI space, somebody can be this space. And what do we do to get those leaders in India? What do we do to foster them? What do we do to put our whole mind and soul behind them? Silicon Valley was made by 5 people. There are not many. Go back to 1963, there were 5 people, the 7 rebels from Fairchild. So the point I think is India needs those rebels. We need to find those people and we need to put everything behind them. And then I think Indian government can do. And Dr. Mitra, off to you.
Silicon Valley was made by Fred Thurman.
That is true. But I'm talking about the commercial 7 companies that came out of the Fairchild.
I understand.
So I think fortunately we have exactly 5 people on this panel, Naveed.
All right.
I think thank you so much, all of you, and not just this panel discussion. As we build upon the momentum which has been created in last 1 year or so by the government, by the whole participation of industry, academia, and government to come up with this set of policies, we will need your continuous support and guidance to basically move in the right direction. Be it the product, be it the technologies coming from the people like Stanford. I would love to see a very structured collaboration between one of the academic institution in India with Stanford to develop some of these technologies going forward. And same with people like eFabless or OpenFPGA, and taking some example from basically academic to this thing, right? I always remember the way sci-fi evolved, right? Sci-fi, RISC-V was a great idea, but it was kind of a little bit university domain. When it came in the commercial domain, right? Now it is changing the world, right? I think we need to have those kind of the models to make basically things happen. Yeah, developing a core in university and all those things or setup is okay, but taking it out and creating a complete ecosystem around it, we need basically efforts like that, and we need your experience, support, ideas on a continuous basis to make this journey happen. Thank you so much for joining. We really appreciate you joining, and any questions for the audience, you can send to the EFI and we'll try to get it answered. So you have some suggested questions you have curated?
Yes, it's already there in the chat window, Satya. So the question is, it looks like steep investment and delayed returns when it comes to silicon products, right? How would you control cost? I think to some extent this got touched, but if somebody can elaborate. Naveed, you want to go with this?
I think we should attack those questions which are smaller in investment. I mean, let's not go after 3 nanometer. If you go 65 nanometer, maybe we can do a product in 5 million, which is doable rather than trying to something that needs 150 million. So that is my position. That let's start small, take a baby step, and go from there.
Absolutely.
I'll also add to this, identify a application which is low complexity but high volume, and go and attack basically those problems for a short term. Medium term, again, do medium complexity chip, and long term is all for Subhashish to take care of it.
Great. Mike, you want to add something, Mike?
I was just going to say, in supporting Naveed's point, there's 2 ways that actually works. One is exactly what he said. You go for the simple products. One of the things we're already seeing, we had someone do a design on our platform. I don't think I could say much about it, but they did it in 130, super cheap, and that individual, a professor, Professor Mitra, is actually now going to replicate it on 12. So the other side of that is proof of concept, right? Advance, and then jump.
Sure. Any other question, Chitra?
Great one. There is one more. How to increase supply chain resilience?
I think that's a very broad question, difficult to answer. Supply chain resilience means it's a logistic, it's a production, supply, where it basically it's a very complex question according to me. But semiconductor field is, however we do domestic basically ecosystem build, it's going to remain a global industry. We have to depend on each other. No country can do basically everything on their own. Every country needs to build the domestic capabilities, but still it's a very interdependent system, and we have to find out proper ways of basically, I think generally it gets referred to the chip shortage, right? I think there are ways to handle those things in the future. Now we have learned what the problem is, the solution should also come.
So Satya, my position on this one is that India, like China, like US, like other countries, should do enough to sit on the table.
Yeah.
You do not need to know everything. You just need to have enough so you can sit. Because if you have nothing, you don't sit on the table. Then you are out.
Absolutely.
If you have enough, you can say, well, I control 3% of the or 5%. Okay, then you get invited. If you control 0, you get not invited. So I don't think India needs to think about independence. India needs to think about enough so that you can sit on the table. And I think,
absolutely,
even where we are right now, I can easily imagine in 5 to 7 years and 10 years, we can easily get there. We will be sitting on the table and we will have the respect of others, and then they will include us in the decisions. That's all that is needed. And by the way, one last point, India should pay more attention to semiconductors because it is an issue of sovereignty. And I think because it's an issue of sovereignty, we should somehow think about not just small commercial efforts. Because you're talking about sovereignty, you should be willing to invest 2x and 3x rather than the commercial effort. And I believe semiconductors is an issue of sovereignty for India and other nations as well. If you cannot make critical chips needed for your defense, for your critical banking, your critical telecom, you are dependent on others. And I don't think a nation like India should depend on those things. So I think the investment should be in line with the sovereignty needs of the India rather than just the commercial needs of India.
Well said. Well
I
said.
think we always talk about 3 aspects, right? Economic security, cyber security, and infrastructure security, right? I think 3 things have to be built, because if your infrastructure is not secure, you are going to be in trouble sometime or other, right? Similarly, economic, so many other products depend on semiconductor. It basically requires some kind of sovereignty for economic security and infrastructure purpose. I think that's a high point to end this discussion, that you need to sit on the table, just like United Nations Security Council, you need to have a seat on the table. And also you need to develop basically these critical products and technologies for sovereignty and basically different aspects of economic infrastructure and the cyber security and all of those things. So I think with that, I'll thank everybody. And we have the VLSI Design Conference from 20th February, 1st March and 2nd March. I think you are basically our esteemed guest to attend this conference, and ask all your friends and colleagues to also attend this conference. This is going to be very important occasion in this whole building the momentum and ecosystem towards the semiconductor industry, right? So, and we are getting strong support from the government. Both the ministers from the center are going to be part of this conference, and then we have a galaxy of the global stars who are going to be speaking on this platform. So please join us on 28th, 1st and 2nd. So thank you, everybody. I think we exceeded our time by about 10 minutes, but I think this was one of the most exciting and interesting panel I attended in the last year or so. So thank you again, everybody.
Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you.
Thank you
Bye-bye.
so much.
Bye.
Thanks, everyone.
Thank you.
Excellent hearing you all. Thank you.